Start.
Hi, my name is Pritam Mohanto, and thank you for to give me this opportunity to introduce our project. Our project name is Data Dynamos, and our project code is B42DA001 Data Dynamos. And I am the team lead, Pritam Mohanto, and my other teammates are Abhishek Chaudhary, Bishal Pawar, Ritesh Patil, Gautam Arya. And we chose the project of solar power generation data. We chose the project because solar energy and renewable energy is the future of our energy consumption. This is a very important for our future. That's why we chose this project. And we get the data set from Kaggle. This is the data set, solar power generation data. In here, we have four different CSV files for two different plants. In every plant, we have two separate CSV file like generation data and weather sensor data. We majorly work on plant one dataset. So in plant one dataset, in generation data, we have columns like date time, plant ID, source key, then DC power, AC power, daily yield, ambient time, daily yield, and total yield. And also in weather sensor data, we have some common columns like date time, plant ID, and source key. And we have some different columns as well, like ambient temperature, module temperature, irradiation, etc. Irradiation, etc. And we do all the visualization, EDA, all those things on these two datasets, some in combined and some in differently. And and the more thing will be discussed by my friend Abhishek Chaudhary. So Abhishek, over to you.
Okay, good evening, everyone, and thank you, Pritam, for describing this project. And now I will walk you through the Streamlit tool that we have used to build this project. So one of the key highlight that we did in our project is the important key highlights of the matrices. So here you can see different metrics that are available in front of you on the dashboard. It is like that total DC power, total AC power, unique plants you have, average ambient temperature, average module temperature, and total irradiation per meter square of solar power panels. So by seeing this, user can make quickly grasp important insights, and this will also make sure that user can make decisions much faster and more efficient, and he do not need to think about the large data set. So that is the most important point for this. Apart from that, we also added sidebar option. So user just click on it and use it. And also data selection option is also there. So for example, if the user want to select the date like 15 to 22, then he can clearly see that all the options by just selecting that required dates. Apart from that, there are various checkboxes. There are checkboxes in the data exploration part also, and we have also provided checkboxes in KPI selection. So as per the user requirement, he can see whatever the data he want to see. So for example, if he want to see the total power generated per day, then he just click on it, and here he can see the different options available. So in conclusion, we can say that from this, we try to make our dashboard clean, smooth, and clutter-free for the user. So I think I have make all the points in the Streamlit tool. Now my team member Vishal will walk you through the data visualization technique that we have used in our project. So over to you, Vishal.
Thank you, Abhishek. Hello, everyone. Today I'm going to give you a quick overview of exploratory data analysis process and visualization we use for our solar power plant analysis. First, let's talk about the data loading and cleaning. We began importing by two data sets from CSV files, one for generation data and other for weather sensor data. To ensure our data set was clean and consistent, we dropped some unnecessary columns like plant ID and converted date string into proper date type. Moving on visualization part, we use several types of extract actionable insights. One of the visualization was pie chart. So can you move? Okay. These were used to display the distribution of AC and DC power across different dates. By visualizing the power distribution, we quickly identified which days contributed most to the overall energy production. So can you show the correlation heat map? Okay. In addition, we created a correlation heat map using Seaborn. This heat map provided an overall view of how the numerical sensor data variables such as ambient and module temperature along with irradiation levels related to one another. It helps us to spot any strong correlation that might influence the power output. So over to you, Ritesh.
Thanks, Visha, for giving me a chance. As Vishal tells about the how's the visualization was. Now I will talk about the KPIs that we have generated through data, and as you can see that the total power generated per day. Per day, we have created the visualization on the basis of the date and the AC power, and you can look in that the AC power we have generated per day. You can see that through the visualization of bar chart. After that, average hourly power output means in an we are generating how much power output. You can see through the line chart, and the red line is describing about the DC power, how much DC power is taking output, and the blue line is describing about the AC power output. After that, the efficiency analysis. We work on how much efficient the solar plant is, and after creating a line chart on a daily basis, we have generated some key insight from that, and we have created a line chart, and you can see that how much efficient the solar plant is. After that, how much power loss is happening during that energy production. You can see that through the bar chart, how much power is we are losing on daily basis. After that, impact of temperature